Through a telescope, Jupiter looks serene. We see swirling bands of cream and orange, the great red spots spinning quietly, and the sharp shadow of a moon passing by. It appears to be a protective, gentle giant watching over the solar system. But as a spacecraft gets closer, the environment changes. Radiation alarms scream. Navigation instruments glitch and freeze. This is the territory of a monster. Pile every other planet, moon, and asteroid onto a scale. Jupiter outweighs them twice over. 1,300 Earths fit inside it. During formation, it neared stellar ignition. Just 80 times more mass would have ignited nuclear fusion, creating a binary star system. Because it sits so close to that stellar threshold, it lacks a solid surface. It functions as an active, hostile force of nature. Jupiter's destruction begins millions of miles away. Its immense gravitational pull acts as a long-range weapon, bending the trajectories of anything drifting through deep space. In the early solar system, Jupiter migrated inward to where Mars sits today, before Saturn's gravity pulled it back. As it plowed through the inner system, it scattered, smashed, and swallowed the raw material intended for other planets. That gravitational vacuuming continues today. When rogue comets or asteroids drift inward, Jupiter simply captures them, flinging them out into the void or dragging them down into its own atmosphere. We watched this process in 1994, when comet Shoemaker-Levy 9 got caught in Jupiter's grip. The tidal forces shredded the comet into 21 separate fragments. Those pieces slammed into the planet at 60 kilometers per second, leaving impact scars larger than Earth, releasing the energy of millions of nuclear bombs. Even the objects that managed to establish stable orbits, Jupiter's own moons, exist as prisoners to those tidal forces. Jupiter's gravity physically stretches and squashes the moon Io over and over again. This internal friction generates massive heat, making Io the most volcanically active body in the solar system, with a surface that constantly turns itself inside out. Gravity here dictates the life, death, and structure of worlds across the solar system. Before a probe reaches the atmosphere, it hits an invisible wall, the magnetosphere. Jupiter's magnetic field is 20,000 times stronger than Earth's. If it were visible to the human eye, it would look larger than the full moon, extending millions of kilometers until it engulfs the orbital path of Saturn. This field captures charged particles from the solar wind, accelerating them to near light speed. These concentrated radiation belts deliver a lethal dose to an unprotected human in minutes. To navigate this environment, NASA enclosed the Juno spacecraft's electronics inside a 200-kilogram titanium vault. Even with that armor, Juno can only survive rapid diving passes before it must retreat to safety. Older probes were simply consumed. When the Galileo spacecraft plunged into the atmosphere in 2003, it absorbed a radiation dose equivalent to 25 million dental X-rays before being crushed and vaporized. On Earth, a magnetic field makes life possible. On Jupiter, it functions as a meat grinder for anything that enters its domain. If you punch through that radiation and reach the cloud tops, you enter a zone of supersonic chaos. The Great Red Spot is a storm large enough to swallow Earth whole, and it has been churning for at least 4 centuries. Jet streams tear across the planet at over 600 kilometers per hour, walls of gas moving faster than the speed of sound. There is no solid surface to crash into. There is no ground waiting for you at the bottom. As you sink, the atmosphere gets thicker and heavier. The pressure multiplies with every kilometer, pressing in from all sides until it becomes an inescapable vice. At a certain depth, the weight of the atmosphere forces normal chemistry to break down. Hydrogen gas gets squeezed so violently that it transforms into liquid metallic hydrogen, becoming a conductive metal. Jupiter's interior operates on physical laws reserved for the cores of stars. Jupiter is a hard boundary. We can observe and map it, but never inhabit it. Why spend millions sending probes to a place guaranteed to destroy them? Because Jupiter preserves the specific high-pressure conditions of the early solar system, offering a primary source for understanding how gas giants form across the galaxy. Juno's data reveals a fuzzy, diffuse core that is likely still absorbing the pulverized remains of ancient impacts. This radioactive storm has been churning for 4.5 billion years. It was violent before life existed on Earth, and it will remain deadly long after we are gone. When you look up at that bright point of light in the night sky, you are looking at the king of the planets. It holds that title because its sheer violence ensured nothing else in our solar system survived long enough to challenge it.